Today's lesson is vocabulary, and we're starting a new unit on special segments in triangles. Okay, so our special segments, we're going to be combining words we already know together and creating words that are new for these special segments in triangles. Okay, so the first one is a segment that is perpendicular to the side of a triangle and cuts the side into two congruent parts. Any point on the perpendicular bisector is equidistant from the endpoints of the segment, and every triangle has three perpendicular bisectors. Okay, so what does this look like? So it is perpendicular, so I go to the midpoint. So I'm going to start, here's the midpoint on this side. So if I say this is the midpoint, these two are equal, and then I am perpendicular, so it's at a right angle. So here's a right angle. What about this side? If I do this side, these two sides are cut into two equal parts and perpendicular. And my third side, I cut it into two equal parts. There we go. And we're at right angles. Okay, let's go on to the next one. So this is a perpendicular bisector. Okay, so the next one is called a midsegment. So I'm going to write perpendicular bisector. So the next one is, this is called a midsegment. So these are segments whose endpoints are midpoints. Of two sides of a triangle. This segment will also be parallel to the third side, and every triangle has three midsegments. Okay, so if I have my midpoint here and my midpoint here, if I connect midpoint to midpoint, and then these two segments will be parallel. And so let's try these two here. If I connect these, oops, I didn't draw it real good, but these two would be parallel. And on my last side here. So here would be a midpoint to a midpoint. And these two would be parallel. All right, my next one is called a median. So a median is a segment who are a vertex of one angle. So they're on the vertex of one angle. And the opposite side and the midpoint of the opposite side. So they go from a midpoint, a vertex, to a midpoint. Oops. Midpoint to the opposite side. And every triangle has three medians. So if I start at a vertex and I go to a midpoint, this is my median. If I start at a vertex and I go to the midpoint, this is a median. I start at a vertex and I go to the midpoint. This is the median. Okay, next one is an altitude. This is a segment whose endpoint is a vertex. Of the segment, and it is perpendicular to the opposite side. And every triangle has 3 altitudes. So I start at a vertex, and then I'm perpendicular to the opposite side. I start at a vertex, and I'm perpendicular to the opposite side. And I start at a vertex, and I'm perpendicular to the opposite side. Okay, the next one is called an angle bisector. This is a segment that bisects, so that cuts in half an angle of a triangle, and it has one point at a vertex. Any point on the angle bisector of an angle is equidistant from the sides of the angle. And every triangle has 3 angle bisectors. Okay, so if I want to bisect this angle, I would be cutting this angle into 2 congruent parts. I'm going to bisect this angle, be cutting it into 2 congruent parts. I'm going to bisect this angle, cutting it into 2 congruent parts. Okay, so I drew all of these separately, but if I draw them all in one triangle, I have a lot more going on. So with my perpendicular bisector, if I drew all 3 of the perpendicular bisectors on one point, on one triangle, what I would see is these would all intersect. So that point where they all intersect, and we actually call that concurrent when there's more than 2. And I call that, this is called the circumcenter. On my mid segment, I don't have a point of concurrency. My median, when I draw all my medians on, the point that all the medians meet is called the centroid. The point of concurrency for an altitude is called an orthocenter. And the point of concurrency of an angle bisector is called an incenter. Okay, that's all for today.